What do you say, YouTube? In this video, we're going to be covering the essential tips and tricks on how to learn organic chemistry. Let's go. A lot of people think learning organic chemistry is hard, but I think it's just hard work. And when you think about it, a lot more like learning a language. Learning the words of this language is like learning the functional groups. Constructing sentences are forming chemical reactions, and then the combinations of these in logical orders are necessary to make paragraphs. Let's illustrate this by example. Here is a two-step reaction sequence. First is the ozonolysis of 2-butene, which is an alkene, with ozone to form two equivalents of ethanal, an aldehyde. Then this ethanal is reduced with sodium borohydride to form ethanol, an alcohol. It's okay if you're not familiar with these reactions or these functional groups yet. The point is that this reads like a sentence, where we really need to understand the meaning of each of these fundamental groups, or words, before we can begin to appreciate the reaction sequence as a whole. Those who become fluent in this language can create some truly wonderful expressions. Here is a classic synthesis of a very complicated molecule by R.B. Woodward that took them 29 chemical steps, or sentences, to reach the final molecule called strychnine, an infamous poison familiar to those readers of classic crime novels. For those interested, I put a link to this work below. If organic chemistry is like a language, how do we learn a language? Well, the first thing you need to do is memorize the words, which in this case means the functional groups. In my experience, the best way by far was by using flashcards. For example, I would write the name of a functional group on the front, like alcohol, and then draw the chemical structure on the back. It's also handy that these cards function in reverse. Then to learn reactions, you could instead write the chemical reaction on the front with no reagents, and then on the back draw only the reagents. Okay, this is an essential set of words or functional groups that every organic chemistry student must know by heart. These include hydrocarbons, like alkanes, alkenes, alkynes, and benzene. When carbon forms single bonds with oxygen, we get alcohols, ethers, and epoxides. When carbon forms double bonds with oxygen, we get functional groups like aldehydes, ketones, carboxylic acids, esters, and acid chlorides. The essential nitrogen-containing words are amines, amides, nitriles, and nitros. Words with sulfur are sulfides, thiols, and sulfates. Lastly, there are phosphates. I recommend knowing this set of functional groups by heart as soon as possible. To do this best, review the cards, and then sleep on it, and then review them again the next day. You need sleep for your brain to be able to process and make deep, long-lasting memories. Another useful way for accelerating this memory process is by mnemonics and word associations. For example, it's useful to remember some of the trends on the periodic table. The order of the group 7 halogens, for instance. Mnemonics work great here. Funny clowns broil innocent ants. Or instead, maybe funny clowns break into attics. You can create a more personalized mnemonic, and it will stick with you much better. A tip somebody once told me was if you include swear words or taboo words, they seem to be much easier to remember. I can't even repeat the mnemonics that I use. If you're interested in some more tame suggestions, there's a Wikipedia page with a bunch of useful mnemonics in chemistry that I've included in the description below. Here's an example of word association. A common mistake for students in organic chemistry is confusing ethers with esters, since they sound alike. A professor I had once told me that if you look at the structure of ethers, the lone pairs look like the ears on a bunny, and you can think of it as an ether bunny. And this helped me remember the difference. You can consider using this strategy in other instances when you encounter some memory obstacles. Lastly, I really didn't appreciate at first how useful a model kit can be. Visualizing molecules in 3 dimensions is absolutely crucial, and it's pretty hard to do in your head alone. For example, here are 2 generic tetrahedral centers. Are they the same molecule, or are they enantiomers, which is not superimposable. Building a model of the structure on the left will really make the realization that these are the same molecule much faster, since you can just do a bond rotation and get back the molecule on the right. If you have any tips that I didn't include, make sure to leave a comment. If you enjoyed this video, please hit the subscribe button. Thanks for watching.